Okay, this is the notes for section 3.1, and this whole chapter we're going to talk about systems of equations. A system of equations is two or more equations with the same variables, and to solve a system of equations with two variables, we find the ordered pair that satisfies all of the equations. There are three different ways we're going to talk about solving systems of equations, and the first way that we're going to talk about is to solve by graphing. Okay, so it says one method for solving a system of equations is to graph the equations on the same coordinate plane, and the point of intersection represents the solution. Okay, so let's look at an example. First thing we're going to do is solve the system of equations by graphing. So the first thing for each of these, first of all, I have two equations that I'm going to be graphing, and before we can graph, we have to solve for y. So I'm going to look at this first equation. We want y by itself, so the first thing we're going to do is subtract 2x. And then I have negative y equals negative 2x minus 1. I can't have a negative y, so I'm going to divide everything by a negative, which is just going to change the signs on all of my numbers. Okay, so let's go ahead and graph that. Now here's the deal. When you solve systems of equations when graphing, you have to be very accurate. And so you're going to want to use a ruler because you want your lines to be nice and straight, because we're going to see where those two lines intersect. And if your lines aren't very straight, they might intersect at the wrong point. So we want to be as accurate as possible. Now, I just said that, and when I do this on my smartboard, it's very hard for me to be really accurate. First of all, my pen is very, see how fat it is? It's very fat, and I can't use a ruler. So that might affect my graph. We'll just have to kind of wait and see how it looks. So my first thing I always graph is the y-intercept. My y-intercept in this case is 1, so there's my starting point. We should know by now that my slope is 2, which means from this point I go up 2 over 1, up 2 over 1. Or I could go down 2 to the left 1, down 2 to the left 1. Okay, so it's very important when you graph these that, to the right, up 2 over. Okay, so when you graph these, you don't want to just graph a little portion of the line. You want to make this line all the way across your coordinate plane. All right, now I'm going to see how close I can get these because I'm just guessing where my pen needs to be. Okay, and I'm going to, my line's not very pretty, but you guys will do so much better. There's my first line, okay? So now we're going to solve this second equation. On this second equation, I need to solve for y, so I'm going to subtract 5x. And now I have 2y equals negative 5x minus 16. Then I need to divide everything by 2. So I have y equals negative 5 over 2 times x minus 16 over 2 is 8. Now on that same graph, I'm going to graph this equation. We're going to look at our y-intercept first. Our y-intercept is negative 8. That's the very first thing we always graph. From that point, I'm going to graph my slope. My slope is negative 5 over 2. So since I'm going to run out of room if I go down 5, I'm going to go up 5, 1, 2, 3, 4, 5, to the left 2. Up 5, 1, 2, 3, 4, 5, to the left 2. I'll do one more. 1, 2, 3, 4, 5, to the left 2. Now here's the deal. We can tell just by looking where these two lines intersect. It's that point right there. I'm going to go ahead and draw my line in. So your answer will be the ordered pair at which these two lines intersect. So the ordered pair where they intersect is this point right here, we already decided, and that's the point negative 2, negative 3. Now, what does that mean? That means if I take this x value and this y value and plug it back into these two equations, it's going to give me a true equation for both of them. Okay, when I plug in negative 2 for x, negative 3 in for y, whatever I get is going to equal negative 1. And when I do it over here, whatever I get is going to equal negative 16. So this pair, this ordered pair, works for both equations. Okay. Let's go to the next example. Okay, so on this one, systems of equations can be classified by the number of solutions it has. So they talk about consistent and inconsistent systems. A system that is that is consistent if it has at least one solution, and inconsistent if it has no solutions. So let's talk about what a graph would look like. That's pretty bad. Let me get rid of that. What a graph would look like if it doesn't have any solutions. Okay, well, a graph with no solutions means that the lines never intersect. So I might, if they never intersect, can they be parallel lines? Okay, so that's an example of an inconsistent system because it has no solutions because they never intersect. Then it says if it has exactly one solution, it is independent. One that has exactly one solution is just like the problem we just did. If I have two lines that intersect at exactly one point, that would be independent. Then it says it's dependent if it has an infinite number of solutions. Now, infinite number of solutions means that it doesn't just cross at one point, it crosses or intersects at an infinite amount of points. So two lines that would cross at an infinite amount of points would mean that it's the exact same line. I have one line lying on top of the other. So they intersect at an infinite amount of points. So that's what consistent and inconsistent would look like, dependent and independent. So what they want us to do on example 2 is they want us to classify these. So let's look at A. Graph the system of equations and describe it as consistent and independent, or consistent and dependent, or inconsistent. Okay, so that's a lot of words, but let's graph it first, and then we'll go back and look at the notes. So this first equation, I need to solve for y, so I'm going to subtract 4x from both sides. 3y equals negative 4x plus 24. Divide by 3. So I have y equals negative 4x over 3 plus 8, because 24 divided by 3. So I'm going to go ahead and graph that. So I know my y-intercept is 8. That's my first point. My slope is negative 4 over 3, so I always go up or down first. So I go down 4, 1, 2, 3, 4, over 3, 1, 2, 3. Down 4, over 3. Okay, so there is that line. All right, so now let's look at my second equation. We have to solve for y. So I'm going to add 3x to both sides. That gives me, I'm going to write over here, 5y equals 3x plus 30. And divide everything by 5. I have y equals 3x over 5 plus 6. So now let's graph that. My y-intercept is 6, and my slope is 3 over 5. So I can go up 3, 1, 2, 3 over 5, 1, 2, 3, 4, 5. Or I could go down 3, 1, 2, 3 to the left 5, 1, 2, 3, 4, 5. Okay, I'm going to draw that line in. Now, in this problem, they didn't ask us what the solution was. They just want to know, is it consistent and independent? Is it consistent and dependent, or inconsistent? So let's go back up and look at the definitions. It's consistent if it has at least one solution. So I know this has a solution because they intersect. So I know it's consistent. If it has exactly one solution, it's independent. If it has infinite number of solutions, it's dependent. I have one solution, so this is consistent and independent. And that would be my answer for that one. Okay, so here's what I want you to do. I want you to finish part B. So the first thing you need to do is solve for y in each one, graph them, and then classify it as consistent. Let's see, what did it say? Consistent and independent, consistent and dependent, or inconsistent. Okay, and then I will check this tomorrow when I'm grading your notes.